The George Lone Experience.
Welcome to our 71st show. We are really struggling to find guests for our lockdown podcast. So today we have a special guest, Nisha, with us, a math student and all-around nerd. It's great to have you here today.
Yeah, thanks for having me.
Also, very excitingly later, the real star of the show will join us. Sorry. That's right, the father of calculators himself will be here.
George, sorry, George. It's actually calculus, not calculators.
So not the inventor of, like, this.
No, not that.
Right, okay. I can see you're looking forward to this, Nisha, so that makes one of us. Now, before we get into the really exciting stuff, Nisha, have you ever tried DMT? Because I had this amazing trip the other day and I really think I've contacted aliens.
No, I'm not sure I have.
Okay, do you at least have like an interest in MMA? The fight the other day, oh my god, wow. Some of the punches thrown and like...
George, what has this got to do with maths?
Right, sorry, I too tend to get distracted. Now, our other guest should be here any minute. But before that, Nisha, can you tell us this is about calculus? Am I saying that right?
Yeah, that's right. Well, calculus is a part of mathematics that deals with finding derivatives and integrals of functions.
Interesting. Now, what is a function again? And derivatives and integrals? Obviously, just to remind some of our listeners, not me.
Well, a function in its simplest form takes an input, takes it through a few steps, and then gives you an output. So, for example, the function x squared, it will take any number x and it will just square it. So like 2 will go to 4, 3 will go to 9.
Okay, yeah, I'm following. But what has that got to do with derivatives and integrals?
Right, so if we draw the graph of a function, say if we stick with x squared, then the derivative of the function is the rate of change of the function at a singular point. So it's kind of like the gradient of the tangent of the function.
Okay, like so how steep the slope is?
Exactly. So the integral of this function will be the area underneath the curve between 2 points.
Oh, that's actually pretty interesting.
Don't sound too surprised, George.
So, what is the point of all of this?
Well, it has loads of applications. For example, the rate of change of velocity is acceleration. So if you have a function showing the velocity of like a car, if you can differentiate that function, then you'll get the function of acceleration. So in other words, you would say that the derivative of velocity is the acceleration.
And what about an integral?
So you can kind of think of it as like the opposite. So if you were to integrate acceleration,
you get velocity.
Exactly, yeah. So I can show you some examples if you want.
Okay. I guess that might be useful for some of our listeners.
Okay, so if we have the function of y is 3x squared minus 2x, it would have this graph.
Okay.
And it basically means that you can pick an x value and find its corresponding y value on the curve. So for x is 1, y is also 1. And then for x is 2, y is 8. And you go on like that.
So is that differentiating or integrating?
It's neither. I'm just explaining what the function is.
Yeah, I thought so.
Anyway, so if we want to differentiate the function, say at x is 1, it's really simple. So we first need to know what type of function we're dealing with. So have you got any ideas what type of function this is?
I think I remember this from school. It's a polygon?
Polynomial.
Yeah, polynomial, that's what I meant.
Right, okay, so now that we know the type of function we have, we can just differentiate it. So we look at each part of the function separately. So firstly, we look at the 3x squared. So you take the 2 down from the power, and then you minus 1 from that power. So that gives us 6x.
Right, okay.
And now the 2x has a power of 1. So technically we can write it as
2x to the power of 1.
Exactly. And then we just do the same thing again. We bring the power down and take 1 from the power, giving us
2x to the 0. So that's just 2 times 0. So 0.
Not quite. Anything to the power of 0 is actually just 1. So we'd actually have 2 times 1, which is 2.
That's a stupid rule.
Yeah, I mean, that's just the maths.
Stupid maths.
So anyway, then we just add the 2 parts back together and we'd get 6x plus 2. That's the derivative, which is denoted as dy by dx. There are other notations for this, but like for the purposes of explaining it to you, like you can kind of use them as the same.
Kind of use them as the same. So what's the difference?
Well, I mean, I'd have to define lots of other things.
You don't know. Well, luckily for you, we have a much better mathematician to fill in the obvious gaps in your knowledge. Welcome to the podcast, the man, the myth, the legend, Mr. Isaac Newton.
Thank you for having me.
It's lovely to have you. So let's get right into it. Tell us about yourself and some of your work in calculus.
Right, so using all of my ideas about the laws of motion, I created the method of fluxions, which is known as differentiation. Taking the fluent and the fluxion, being the variable and the velocity respectively, you can calculate the motion of planets, falling objects like an apple from a tree.
Sorry to interrupt you, Isaac. It looks like there's someone in the waiting room. You all right, mate?
Oh no, not this guy.
I am Gottfried Wilhelm Leibniz, the real father of calculus. Unlike Newton, I actually had a mathematical approach to calculus. I used the summer and I found rigorous ways to integrate for mathematicians to use. Newton, your findings are useless compared to mine.
You wouldn't be anywhere without me. I came up with it a decade before you.
What? I published my findings in the 1680s. We all know you copied my work.
Only because I was publishing all of my other findings. You're a one-trick pony, and I didn't expect you to vulture off me.
You're so stupid. I wish the app would hit you harder.
Nobody even knows who you are. I'm so much better than you.
All right, boys, settle down. Let's give Nisha a chance to voice her opinion.
Well, I mean, for starters, if you think about the Babylonians, they studied the motion of planets and how quickly they moved. The ancient Greeks, they used exhaustion to work out the area of polygons and used limits to work out the area of a circle.
I think I'm reaching my limit.
And what about Madhava? He worked out the power series before either of you were even born. Maths is a language that's developed over centuries, and we can't forget the help we were given by our ancestors.
Yeah, I think I'm going to have to mute you boys. Thanks for coming, I guess. I think it's probably best if we call it a day, to be honest, Nisha.
Yeah, I had a really great time. Thanks.
Right, yeah. Thanks for listening, guys, and be sure to come back next time for an exclusive interview with Jimi Hendrix. Bye.
The George Lone Experience.